Hello everyone, welcome back to JTech class. My name is Javier and I'm welcoming you. Today we're going to continue with our intro to computer networks on this video number 2 of the series. And we're going to go into more detail about network protocols. So let's start by remembering what we saw in the last video. Let's do a recap. Where on the last video we looked at computer networks and what they are. We also took a look into what are standards and protocols, as well as we did a full view on the OSI model. Today we're going to learn more about protocols, specifically the TCP/IP protocol suite. So what are network protocols? Network protocols are like the rules and standards of communications. Take, for example, a conversation between you and your friend. You first need to agree on a language to be able to understand each other. Then you must follow some standards of communications like proper grammar or saying hi before starting to talk. Protocols can be grouped together in something called a protocol suite. But what are protocol suites? Protocol suite is no more than a group of interrelated protocols that are necessary to perform communication. The protocol suites are implemented by computers and other network devices. The protocol stack shows how the individual protocols within a suite are implemented. This way, we can look at them like layers, where each high layer depends on the one lower layer. One example is on the image on the right. At the bottom, the physical layer, we have two people. Each have a voice that can pronounce words out loud. In the middle, we have the rules, the language agreed upon. And at the top, we have the actual words that can be spoken. This is the content of the message, like, where's the coffee? Let's see some examples of network protocols. Here we can see 3 network protocols. These are some of the more used ones, but there are many others. Let's start by talking about HTTP, which is the Hypertext Transfer Protocol. This protocol allows you to see web pages. Then we have the TCP, the Transmission Control Protocol. This one allows the web server and the client to have a knowledge of which packets have been sent in which order, which have been received, and which ones need to be sent again. Then we have the IP protocol, the Internet protocol. This one sometimes is confused with IP addresses like IPv4 and IPv6. Even though IPv4 and IPv6 form part of the Internet protocol, they have different meanings. So how do protocols interact? If we look at the image on the right, and if we go from top to bottom, we have HTTP, which governs the way a web server and a client, your browser, interacts. This protocol defines the content and formatting of the requests and responses that are exchanged between the server and the client applications. At the same time, HTTP relies on other protocols that governs how the message is transported. TCP is our next protocol in the list. This protocol manages the individual conversations between the client and the server by dividing the message in smaller pieces. These pieces are called segments. These segments are exchanged between the server and the client based on the TCP requirements of size and rate of the message will be exchanged between server and client. Then we have the IP, the Internet protocol. This protocol is responsible for taking those TCP segments and putting them in a package with an address and driving them to their destination. Then we go to the lower level, where we have Ethernet. This one is a network access protocol that basically takes the IP packets and make them possible to transmit on a physical cable. So let's look at some protocol suites and standards like TCP/IP, ISO, AppleTag, Novell, and there are many others. There are many protocol suites out there. Many of the protocol suites are created by specific vendors like Cisco or Apple, and will only be implemented on the equipment that those vendors create. But as we saw before, Protocol suites are no more than a group of rules that govern communication between devices. But how do we create that group of rules? Well, we put different protocols together, but those protocols need to work with each other. Let's talk about the most used one, open source protocol, the TCP/IP. TCP/IP protocol suite, as you can see on the image here, is based on 4 layers: application, transport, internet, and network. Those layers have different protocols inside of them. There are many protocols, but here we got some examples. If you don't know what DHCP or TFTP means, please enter these names on Google and you will be able to find a lot of information about them. If you remember from the previous video, we talked about the OSI model and how it is a reference for all other protocol suites. Here is a comparison of how the TCP/IP protocol suite encapsulates all 7 layers of the OSI into 4 layers of the TCP/IP. We have the application layer, which in the OSI model makes a reference to application, presentation, and extension. So these 3 layers on the OSI are encapsulated on a single layer on the application layer on the TCP/IP model. Then transport and network correlate to transport and network on the OSI. And then we have the network interface, and we have this one to correlate with data link and physical on the OSI model. So how does the communication process between the TCP/IP protocol suites happens? Well, let's watch this little video and find out. So now we're gonna see how a web server sends and encapsulates packets to send to a client. First, we're gonna get some data and we're gonna put it inside of data packet. Then the data packet is gonna get encapsulated inside the HTTP protocol, which is gonna add a HTTP header to the packet. Then this is gonna get encapsulated inside a TCP protocol, which adds a segment to it, which then is encapsulated inside the IP protocol. All these encapsulations adds a header, like Ethernet, where you will add the header for the MAC addresses. Then this whole packet gets converted to zeros and ones to send over a cable. Now let's watch how a web server or how the client receives and then de-encapsulates the packet. So the web client receives all this data as binary and then checks every single header. It starts by the Ethernet, then by the IP, then by the TCP. Then it checks that it's an HTTP protocol, and then it shows the data in the web browser. So what's next? On the next video, we're going to talk about network devices, like switches, routers, and such. We're going to see on which layer of the TCP/IP protocol suite they are located and how they work. Remember to subscribe to the channel to keep up with up to date with the latest videos. And if you like this video, please share the video with your friends and give us a like. Feel free to leave your thoughts on the comments, as well as any recommendations or suggestions. Thanks for watching and have a great day.